Hey, my bad. Ah, let's try it again. Yeah. Hey everyone, welcome back to the channel. My name is Darsh Joshi, and today we'll be talking about sets in Python. So let's take a look at my second. I was looking for some good wallpapers, but yeah, before we start, please do subscribe to the channel so that you know what we are up to on the camera as well. 1 second. Okay. Okay, let's get started with sets. I'll just start the presentation. It here. I guess we are good to go. So sets are basically uh, the sets which we use in mathematics. It's the same thing, but in a code kind of thing. We'll take a look at that in our whiteboard. I've plugged in my tablet and let's see how we work with sets in Python. So I'll just declare it sets. Okay, my camera is not working. Anyways, we can work without that as well. That's not an issue. So yeah, sets are basically collection of non-duplicate data, or we can say collection of unique data. So let's say this is our set A. A really bad drawing of a set. Draw it again. That looks good enough. So this is my set A, and I'll draw another set which is we'll call B. So what would happen here is these two are collection of data. This area contains the elements which are unique to A. This area contains the elements unique to, not unique exactly, but which are common between A and B. And this area contains the elements which are unique to the set B and would not be contained in A. So there are some certain operations which you can perform on sets, like calculating this part, the common part, calculating this part, calculating this part, calculating the entire thing but except this part, something like that. You get the point. So let's see what we have in the presentation here. So I should pull up one. Okay. So in the presentation, the first thing we'll be discussing is the definition. So by definition, a set set in Python is a built-in data type which can be used or is used to store a collection of unique data. So this defines a property of sets, which means that it would not be containing any duplicate data. Let's try that out in our VS Code and we'll check that out in a second. Okay. Let's call this set A and we'll put some values inside this. 1, 2, 3, 4, 5, 5, 5, 5, and 6. If I just print it out now, then I should be getting all the unique values only. My run button wasn't working for some reason, so I'll have to check that. So this is what we get. These are all the unique elements from this set. It does not contain the repetitive 5s which we put here. Apart from that, it is just like a list, nothing else. So the next thing we'll be looking at in the presentation is the syntax for this. The syntax for this is like we can define a set. A set can be defined in these two methods, which is using the curly brackets or using the set class. We have already used the curly bracket method, and now we'll go with the set class method. Let's say A is set, and inside this we'll put an array. Something like this. If we run this code, then we get a set again. which is required in our case. So the next thing we'll be discussing is properties of set. What are the properties of a set which we declared in our VS Code? So we already know one of the properties, which is that it would only contain unique elements and nothing else. So properties are as follows, which is unordered, non-duplicates, mutable, and no indexing. Unordered and no indexing basically mean the same thing. Like when I was researching for this video, I found out that set used to be ordered, but after I guess Python version 3.7, they removed all the orderings from set. Now the set which we are using is unordered, which means that all the elements stored here do not follow any certain order of storing. So if I want to print, if this was a list, then what would I do to print one? I would do something like this. Like we'll use the index of the element which we want to fetch. But if I do that in a set, it throws an error, which is that set object is not subscriptable. Subscriptable also means that we cannot use the curly brackets to access the items. We'll have to use so we basically can't use curly brackets here. We can, I guess, try one because one exists inside this. Let's see what happens. It still gives an error because it's mistaking one as the element. If we do this and if I do this again here, then it should print out one, but it would be in the form of a string. It doesn't work this way. Why it doesn't work? We'll be seeing that in one of the future slides. For now, let's keep it this way. So yeah, no duplicates, we saw that already. Mutable, which means that we can add and remove elements from the set. So that's also the topic which we are covering in next slide. And no indexing, we just saw what no indexing means. So let's move on with the common set methods. So set has like 4 methods which are really common. I think there should be 5 methods, but I forgot to add one here. I'll just show that in VS Code. Let's take the example which we are taking in the PPT as well. Taking s equals 1, 2, 3, 4. Let's put it 3 right now, so we can add an element later on. So the method which I forgot to mention in the PPT is length of the set, like how many elements does this particular set contain. How we do that? We do this, and we enclose that in parentheses, and we print that out. For now, the output should be 3 as it is. This is, I forgot to mention it because it's like a common method and I don't think it's too important to be included in the PPT. So yeah, next up, the method which we are using is s.add, s.remove, discard, and clear. We'll be looking at those one by one. I'm not sure why this laser kind of thing exists, but anyways, let's take a look at these like add and subtract and all that. So let's try. We'll need this in the future, so we'll put that here. I'll add some spaces here, and now we can try out all the operations, common methods which we have. So the first method was s.add, and let's say we add 4 in this list, in this set, not the list. And now we run that, and we get all the 4 elements which we have so far. Next method was s.remove, which would, as the name suggests, it would remove the element from the set. Let's remove 2, and let's see what the output is. The output should ideally be 1, 3, and 4, which it is, so it's a good thing. Next up we have s dot discard, and it would work exactly like this remove thing. Let's say we discard 1 this time. Let's run this, and we get 3 and 4, which means then we added 4, we removed 2, and then we removed 1 as well. So that's what we get. And the next part is s dot clear. It would clear the entire set and it would be empty all over again. Let's try that out. So we get an empty set. So yeah, that was some of the most common operations we can perform on a set. Not operations. Operations are covered in the next slide, but the common methods which we can use in a set. So the next thing we'll be doing is we'll be looking at set operations. First, let's take a look at set operations inside our whiteboard. So I'll just take you to the whiteboard. We'll clear this up, entire thing. Now we'll take a look at what set operations are. We have 4 operations in sets. 4 operations in sets, and we'll be taking a look at all of them one by one in our whiteboard. How we do that? We let's say we have 2 sets A and B, and A is 1, 2, 3, and we have a B. B should be 3, 4, 5. So this is a set A. This is another set B. So if I want to execute A union B, union is represented by this in Python. In mathematics, we do this. For now, let me just write it as union so that there is no confusion. Next, we have A and B, which we can call intersection. Next, we have difference, which is A minus B. Difference. And we have another thing which we call symmetric difference, which is represented by this. I'll just write a diff because I want to save some time. So what would happen in these cases? In case of union, what we get all these elements combined in a single set. It would cover this entire thing which I am shading right now. It would cover this entire thing, and the output for this should be 1, 2, 3, 4, 5. But if I want to see what intersection means, then intersection means it would 1 second, let me just clear this up. It's manual labor kind of stuff. Let me just try to clear it with Control Z. Okay, so what intersection means? Intersection, I'll just write all the outputs which we get. So for union, we get 1, 2, 3, 4, and 5 in a set. For intersection, what we would get is the common element between both the sets. So it would be this part. So clear this up beforehand. That would be better for me. So you would get this, this. Then we have difference. Difference means that it would remove all the common elements between A and B and execute or display out only the elements which are unique to the set A. In this case, the output would be, just write diff. For diff, the output would be 1 and 2 because 3 is the common element between both the sets. So it won't include 3 if we are calculating the difference. For symmetric difference, I'll just write it like this so as to save some time. So for symmetric difference, what would happen is it would subtract A from B, B from A, and then put all those together. So that would basically remove this out of the box. So what we would get is 1, 2, 4, 5. Something like this. So let's take a look at that in our VS Code. We understood the theory of it and how it would function. Let's take a look at that from the VS Code perspective. I'll clear this up real quick. We'll take the same examples. 1, 2, 3. B should be equal to 3, 4, and 5. Okay. The first thing we'll be executing is A union B. The answer for this should be 1, 2, 3, 4, 5, which is the exact answer which we predicted in our whiteboard. Next is A intersection B, which is A intersection B. It is represented by the and ampersand, whatever you call it. The answer for this should be just 3 inside the curly brackets. Okay, I'll comment this out so that we have clarity on what we are doing. I'll clear this up as well. And this is what we get for intersection. I'll comment this, copy and paste, then we'll comment this out. The next thing which we are trying was difference, and the output for difference was 1 and 2 inside a set. So let's try that out real quick, and here we go. This is the output which we predicted in our whiteboard, as well as that's the same answer which we are getting in the code. The next thing we'll be trying out is called the symmetric difference. Even I was not aware before researching for this video about what symmetric difference does, but I tried it out eventually and I figured it out that this is what it does. Let's show you the output. It removes the common element from the set and gives out all the unique elements which are unique to both the sets, but does not interfere with each other. Something like what I explained here. So yeah, those are some of the sets and their common operations which you can perform. Okay, so the next thing which we'll be looking at is some real life use cases. I've written very limited real life use cases here, but I'll just explain some more of this. Like if you're working with a shopping cart, you don't want the specific item to be repeated inside the list, right? That's one of the good examples of how we can use sets. Another example would be this second one. This one, I guess, not the second one, first one. To find mutual friends on social media platforms, like how Instagram does, how Facebook does, how every other social media does. What they do is, let's take, this is you, and this is your friend, and this is some random person. Let's call them R, or let's call them random. So what would happen is you would have a certain list of followers. Let's take set for that. So this is you. This is your friend. And this is some random person. Okay, so what happens here is the mutual friends between you and your friend would be these people. The mutual people between you and the random person would be these people. and the mutuals between your friend and that random person would be these people. But all the people common between you three would be these people. I would just erase that all to show it properly. This is the set of people which are unique, not unique exactly, but like mutual followers between you three. So you can like determine if you know that person or not in a way. Like that's a good example for that. Next example is detecting common skills on job portals, which is again a really good example. So let's say it is you versus a company, not versus exactly, but like you get the point. So you have a certain set of skills, and the company has a requirement for a certain set of skills. So what your job search application would do? What it would do? It would go through your skills. It would go through skills required by the company, and based on how many skills are common between the two use cases, not the use cases, but like two perspectives, then it would recommend the job on the basis of what is common between the specified skill sets. That's a good example for this, or of how we can use sets. Moving on is a code challenge which you are supposed to complete before the next video is uploaded. I try to upload every week. I'm not too consistent with this, but you get the point. The code challenge for this video is this. The code challenge is that you are managing two college clubs. One is a coding club and the other is a designing club. Some students are in both of the clubs, and you are supposed to find the students in both of the clubs, find students in only one of the clubs, find all students and count total unique students. That should be pretty clear, like it's pretty easy from what we have discussed so far. So yeah, that's all we had to cover today. And because my camera is not working for some reason, that I can't show my face anymore, I guess, at least in this video. So yeah, that was everything I had to cover in this video, and yeah, please do complete the code challenge. Please subscribe to the channel. I'm trying to stay consistent in this. So yeah, see you in the next one. Until then, you should keep learning and keep growing. So yeah, see ya.